start. Okay. So let me introduce here with us today, we have Nikita Popov. He is a lead data scientist in Yandex search portal, who will share today with us a side-by-side comparison use case for search relevance. I will give the floor to him like in a minute. And also, let me tell you that, as always, first we will have around 30 minutes, 35, the webinar. And at the end, we will have the Q&A session to answer your questions or discuss any concerns on maybe your projects or maybe on these use cases that Nikita will share with us. So don't hesitate to ask questions in the chat or live. So I think we can start. Nikita, you may share your screen, please.
Okay.
Thank you.
Okay, can you guys see my screen?
Yes.
Great. Hi everyone, my name is Nikita. I'm data scientist at Yandex Search Department. I will tell you a little bit about side-by-side comparisons, how we use side-by-side pairwise comparisons in Yandex Search quality evaluation, and our use cases and applications of this tool for our experiments and other stuff. A little bit about myself. I work at Yandex Search for more than 5 years. For all this period of time, I was working on offline metrics of web search engine. Recently, my field of expertise expanded to image and video search engine, construction of metrics offline and partially online. I was a part of a team which developed and maintained big projects on crowd platforms like Yandex Toloka and our internal managed crowd platform like search relevance, the side-by-side project. Also, I have me and my colleagues conducted a tutorial on recent the WebConf about search metrics, about offline metrics for search web search engine. I will briefly. Today we'll talk about search quality evaluation. How do we perform it at Yandex Search? How we use side-by-side comparisons to improve our search engine, how to generate hypotheses and insights, how to detect and resolve problems. I will tell you a little bit about the difficulties of using side-by-side comparisons related to crowdsourcing, like which problems, which errors we observe when we use crowdsourcing to obtain pairwise comparisons. And I will also share with you some tips for making side-by-side project on crowdsourcing platform, how to get the most of crowd signal using this type of setting. Yeah, and you can ask questions anytime you want, either in chat or by voice. So let's begin. Let me tell you a little bit about what Yandex Search is right now. Well, it's a service with decades of history. Like the first the first search engine was introduced at the end of previous millennium. Right now, it has more than 20 years of history of development and more than 10 years of expertise of using crowd labels, managed crowd labels, and I think approximately like 7+ years of using crowdsourcing tools to improve quality of web search engine and related stuff. Right here you can see the state of search in the state of international search translated to English language. Russian version of search is much more detailed. It has lots of one box elements, lots of interactive elements, and not only links to external websites, but the core of search, core of Yandex search looks like this as of today. Yeah, so let's start talking a little bit about quality evaluation, how we do it at Yandex search. Here you can see our pipeline of accepting new features, new versions of search engine, how we test it, how we deploy it to users, and which versions of features are going live and which are discarded and not used later. Usually using the crowdsourcing labels, we have some training data, which helps us train our machine learning algorithms, which we use in our ranking system. For example, we have several versions of our search engine, and we use offline methods to evaluate quality before releasing it to users, like when we want to make sure that there is no critical errors, nothing wrong on larger scale with a new model, a new version of search. After testing our new version using offline evaluation, we conduct an A/B experiment, and successful A/B experiments, successful A/B experiment allow us to deploy the new functionality to production. Why do we use offline metrics? Why do we use offline quality evaluation? Why is it not sufficient to use only online experiments, online metrics? There are few points why do we need it. It divided into 3 categories. First one is the following. Online signal, online metrics are usually not enough just because it's an implied signal, implicit signal. We cannot be sure that the response that we showed our user was enough for him or her to achieve its goal. We can only assume by some implicit feedback that the user was satisfied with the result. Compared to that, offline metrics, offline measurement can provide us explicit signal. We can use crowdsourcing labels to tell us exactly whether our response was okay, or is there some critical error, some bugs, or the result, the answer was not sufficient enough for user to solve its task. Also, online experiments usually tends to be longer than offline measurements. Like online experiments, we conduct minimum 1 week, usually longer. Well, on the other hand, offline measurements can be obtained within 24 hours in our pipeline. The next category of reasons why we use offline is that it helps us understand what exactly wrong with our service, like dissatisfaction analysis. Using crowdsourcing labels, we can filter responses that are not good enough to be considered sufficient for users. And using this selection of examples, we can find insights and generate hypotheses how we can increase the quality of our service. And the last but not the least reason why online metrics is not enough, it's some biases of online signals. For example, online metrics tends to be favorable for clicks, and if we are focused only on increasing clicks in our service, we promote content that is like clickbait or stuff like that. Also, only judged by user behavior, we cannot detect fraud content like fake news or stuff like that, and some other manipulations that can be harmful for our users, which are not detectable using only online signal. Next, I want to share with you our model that we'll be using later, so we can be in the same context. We will model our work in the following. We will assume that we have a user who interacts with our service by sending some kind of query to our service. And our service responds with a list of responses, or if we are talking about some ranking algorithm or stuff like that, or it can be a single object, single response, if we're talking about some question and answer systems which are not just ranking objects, and more like a answer generation rather than sorting documents by relevance. And our task which we want to solve is to create a overall measure of quality. How well do we solve user task? And we divide it to several subtasks. First of all, we want to obtain a single object quality measure, like whether one of our responses that we provided to our user is good or bad for user query. And after we develop this quality measure of single object, we need to aggregate it to an overall measure of our response, like to create a metric. Yeah, so this is the model. The basic element quality measure is relevance, like how relevant the presented document is to a user query. But unfortunately, it is not enough for us to evaluate quality of our service, for example, for following reasons. Sometimes content can be relevant, but very questionable. For example, generated by non-expert or frauder, or some kind of unverified source. And the content of this document can still be relevant, but we cannot trust the information on this document, so it is not good to show this kind of documents in our search response page. Another reason why the basic relevance is not enough is over a period of time, some object might lose relevance to a user query. For example, when we're talking about news queries or some events that are happening right now, and in a week or so, there will be some other content that will be more relevant than the content that exists right now. And there is an aspect of freshness of a content, like relevance can be time bounded, and what's relevant today won't be relevant like tomorrow or in a week. Another reason why relevance, basic relevance isn't sufficient is for example, when we are trying to assess difficult queries requiring an expertise using the crowdsourcing tools, crowdsourcing platforms, we can obtain judgments that are incorrect or does not match the verdicts of an expert. So we can, if we are not using an expert crowd, we can get a huge bias towards stuff that is understandable by non-expert workers, but isn't relevant to an experts. And the last reason that I present here, the reason of our today's session, is that point-wise assessment, point-wise quality measures of our service responses might not be enough to tell us how well service performed overall. Like we can, every single object can be highly relevant, but the total response might look not so great and can be made can be made better. So the question is, why do we need some other stuff rather than relevance, and why do we might need side-by-side comparisons related to search relevance assessment? As I said, point-wise judgments cannot be sufficient enough to estimate the overall quality of response for service, and here are some examples where it can be seen. For example, if we have some duplicate entities in our response, like as you can see on the screenshot of our response, we have 3 almost similar links to the same content. We have an original Wikipedia page, we have an English version of a Wikipedia page, which is the same for user as a global Wikipedia page, and at the end of the search result, we have a Deutsch version of Wikipedia, and while those links are highly relevant and what user might want to see in search results, but user don't want to see the copies of the same entity. And if we only judge a point-wise measure of quality, we won't catch those aspects, like whether our response is diverse, whether we have diverse entities, or is there duplicates which can be removed, and the overall experience of the result would increase. Another example of problems with point-wise approach is when we have a formally relevant object, but if we look at our results as a whole, we can see that this formally relevant object is not what user might want to see in the search results. For example, when we are trying to find stuff about some technical topic, and if we will present a user an element with the pictures of this technical topic, it might be relevant since it has pictures about the search topic, but we can assume that the user might want to read a lot about this topic rather than just see a summary in one image or so. So this object is relevant, but it will be better to remove it rather than get a positive score in point-wise approach. So let's move on to our main topic of our discussion. Let's talk a little bit about side-by-side comparisons, how we tackle these problems, how exactly do we use side-by-side comparisons in order to increase quality of our product, of our service, of our search engine. Briefly remind you what side-by-side is. It's usually a pair of objects and we want to select the best suitable alternative among those two objects, which is more relevant to a user query. This is a basic example of general side-by-side comparisons. If we are talking about search side-by-side, this is how it looks in our production pipeline. We show two examples of our search engine result page, and ask our users which result is the most suitable option, which one is better than the other. Like on this example, you can see an example of our search result page with a translation tool. One example is less detailed, and the other one has some examples in addition to just the translation. A little bit about scale of this pipeline, how much objects we obtain, how much experiments do we conduct, and how fast do we obtain results. Right now, we obtain approximately 1 million comparisons per week. We have approximately 10,000 workers weekly solving our tasks in our project at the Yandex Toloka. Judging from a perspective of experiments, we conduct more than 100 experiments on a search side by side, and 300 experiments total side-by-side experiments, which is not only side-by-side comparisons of search result page, but also some other hypotheses, some other products, some other services, and so on. In terms of time, we usually obtain results for search side-by-side in 24 hours, and for a brief for smaller experiments when we test potential designs that we want to implement and to run on real users, when we are selecting the best design for our future implementation, those kind of experiments can be conducted in a working day. Yes, I think I see a question, right?
I think Shiroi raised his hand.
Yeah. Do you have any question? I don't think that we're hearing you right now.
Can you guys hear me now?
Yes.
Yes. Okay. For each experiment, how many queries do you guys normally have?
Usually several thousands.
Several thousands of queries. Okay.
Yes.
Cool. Thank you.
Okay. So moving on. As I said, we usually obtain results in 24 hours for search side-by-side experiments, and for design side-by-side experiments, we can obtain it like in a working day. You can run this experiment in the morning and get the results at the end of the day. Moving on. Let me tell you a little bit about the use cases of side-by-side comparisons. We use it mainly for three use cases. Like we use it to estimate an overall quality of our search engine, how well it performs, and we obtain comparisons in order to estimate a key point indicator value in order to plot how successful our search is and to track it over time, which releases increased our metric, our key KPI metric, and which releases decreased it, or if or some other releases, or like other stuff that can affect the performance of our service. The second use case where we use questions, where we use side-by-side is dissatisfaction analysis. As I was talking in the beginning of my talk, we use side-by-side markup in order to find potential problems with our search engine. We select queries where our search engine performed poorly compared to something. And the last use case where we use side-by-side comparisons is acceptance. Before we release, when we want to release new features into online experiments, we use side-by-side tool in order to know whether everything is okay, whether there is no bugs, is there an expected changes in our product, is the feature working correctly, and everything working as intended. Here is a little diagram showing us how we use side-by-side in our pipeline. As I was saying, we use side-by-side to test hypotheses. For example, if we come up with an idea that we want to change some aspect of our search engine, for example, we want to redesign some block in our result page. First of all, we make a quick example, mock-up, something not functional, but something that will show the idea how it will be working when we implement it. So we perform a design side-by-side where we compare not the actual implementation of a feature, but some sketch, some idea which can be modeled in a short period of time without the need of implementation of this feature. And those hypotheses that are good in terms of side-by-side comparisons usually go to an implementation step when we are actually using some front-end resources, some back-end resources in order to implement this feature live, so we can run an online experiment and test it on a broader scale. After this feature is implemented, we are running traditional search side-by-side on a larger set of queries, and the successful features that have been effective in terms of side-by-side comparisons are usually go live into A/B test, and if everything is okay, we release it into production if A/B experiment tells us that everything went as expected. Next, I want to talk you about a little bit, and I want to talk you. Next stuff I want to discuss is some difficulties that can be stumbled upon in a crowdsourcing aspect, in crowdsourcing using the pairwise comparisons, like what can affect the resulting quality of this tool, what problems can be faced when implementing this kind of project in crowdsourcing platform. And I want to make it a little bit interactive, so there will be some examples which would try to present you the problems that can be faced in the crowdsourcing project. First one is, for example, let's imagine that we want to sort images of people by age. We have pictures of different people, and we want to order it from the youngest person to the oldest person. For example, when we compare these images, it's kind of obvious which one is younger, which one is older. So for the left one is a child, the right one is quite old, and we can almost certainly say that the first image is a person on the first image is much younger than the person on the second image. Here is it's still clear enough which one is younger, which one is older. Like the second image is of a person like of a teenager, and the other one is a more older person. But when we're looking at images like this ones, it's not that clear which one is older, which one is younger. So even so, there is a true answer to the question which person is older, which person is younger, we cannot assess it properly just looking at these images. For example, as far as I remember, the person on the right image is older than the person on the left image. So how does it happen in how does this problem arises in search side by side? It arises as following: when we are trying to compare almost similar web pages, like when there are two links just swapped, and there isn't a huge difference between results of between these two search result pages. If we ask workers which one is better, we will obtain a random signal, since there is no clear difference between those two alternatives. I think I saw a question in the chat. Let me review it a little bit. What metrics do you use for your A/B tests? How do you make sure that one site is reliably better? You are talking about online metrics or something else? Alexander, can you clarify your question? Online. Well, it's easier to answer about offline metrics. We have some variant of relevance of our search engine result page. In terms of online metrics, there are like thousands, if not more, metrics. There are a few key metrics. I'm not sure that I'm in a position to disclose the details of our online metrics. I think it's better to talk with people who are responsible for online experiments. I'm more involved in offline measurements. But well, I think I can say that we using signals like clicks, like absence times, like session amount of session, amount of queries, abandonment rate, and stuff like that. So I think it's a common knowledge. There isn't something completely unique that is not used in similar products to Yandex search. Okay, great. So yes, this problem with crowdsourcing is when we try to compare quite similar objects and force workers to respond with a clear answer. We can obtain a random signal, which will tell us nothing but white noise. Another example of problems that can be faced in crowdsourcing, I want to demonstrate using this question. For example, when you want to choose a new phone, which phone would you choose? An iPhone phone or some Android like Samsung Pixel or stuff like that? Like which phone is better? I think there won't be a consensus like that iPhones are better or Androids are better or stuff like that. There will be people who like Apple products. There will be people who like Google operating system and stuff like that. But it is important to know why do we need to choose a new phone. There is a little outdated example, but I still want to talk a little bit about it. In Russia, in Moscow, we have apps that can write into phone's memory your ticket. Like you can use your phone in order to open gates in the Moscow subway system. But this application works only on Android phones. So, for example, if you really need to use this ability, if you really need to save your tickets into your phone, an Apple model would not satisfy you. You won't be able to do that. So even so, there is like preferences overall. Like some people like Androids, some people like iPhones. In some cases, there is a clear answer, but if it is not stated clearly, people would choose the best model in terms of their preferences, not in terms of the tasks that the tasks that they are solving. So the personal biases, personal preference can affect user workers' output. In search side by side, it's faced this problem arises a lot. Like when we try to compare our system to a competitor system, we usually have a huge bias towards our system because we obtain labels on Yandex platform and we try to ask users that are working on Yandex Toloka which research engine is better, Yandex or competitor. And even so, competitor engine can be better than ours. There is a bias, like company bias, like in the same conditions where different system performs similarly, people tends to choose our search engine compared to competitors just because the market share of our search engine is higher than the competitors, and it can distort the quality signals that you are trying to obtain on a crowdsourcing platform, and the outputs of those comparisons can be affected by this problem. So we have a question in the chat. There is a question like, are these screenshots or live pages? In side-by-side project, we use screenshots. It has some upsides and downsides. Upsides is that we have a fixed state of search engine. So we can like retrospectively compare our systems, our previous responses of our systems to like nowadays responses. But on the other hand, when we use the screenshots, we cannot provide workers the ability to interact with our product, with our service. In some other projects at Yandex, we use not only screenshots, but also like HTMLs, like we provide access to our result page with all the JavaScript, with all the Ajax and stuff like that. But in side-by-side comparisons, right now we are using screenshots. Okay, great. Well, other projects used in elevating search quality, like not in general. We have some other tools that use not only screenshots but also dynamic pages which can be interacted with. Okay, moving on. Another problem that can be faced in crowdsourcing projects. I would like to present you with the next question. Like, imagine that we would like to select the most beautiful picture for our desktop. Like we want to put something nice and to look at it every single day. And we have some options like these two pictures, and we need to choose the one that we like the most. Or, for example, these two pictures, we want to choose the most beautiful one, and we have these two options. If you chose both times the left image, you are an example of systematic bias in this kind of comparisons, when people tend to select something that is easier to choose. For example, we usually interact with objects and our vision goes from left to right. So when we have the similar objects, we with high probability can choose the left objects compared to the right object, and we can obtain a preference to a left object in a setting where there is no real difference between two alternatives. Also, in search, we have this kind of problem, and also we have a problem of subjectivity, like when we have no clear understanding which one, which example of search page is better. Here you can see that one example contains some words in snippets marked bold, and the alternative is without bold text. And there isn't a consensus which one is better. The right one is clearer. The left one pinpoints relevant information in terms of our search engine. And this can also affect the output of the comparisons, like workers' preferences. Subjective preference can highly affect the output of comparisons. And we have another question in chat. Have you seen a reduction in bias if you align the question to the center instead of side? That's a great question. We haven't seen this kind of we haven't seen the reduction of bias to complete absence of the bias, but in the settings that I am showing to you on the screen, we have a bias towards the right image because the options where you choose which one is better, left or right, and they are placed on the right side, and people look at the options on the right side and go from right to left, and we observe the bias to the right. So there are some weird stuff might happen related to the placement of elements in the interface of workers. Yeah. So we discussed a few problems that can arise in crowdsourcing projects. Like when we compare similar objects, we cannot quite similar objects. We usually cannot distinguish them, and this means we have a limited resolution in our signal. We also have some biases, left-right biases, subjective preference, and also we have a problem when we have no clear answer, and subjective responses can affect the output of the comparisons that you gather on a crowdsourcing platform. Let's talk a little bit about ways how we can tackle these problems. How can we reduce those effects on the markup? For example, when we're talking about limited resolution, there is an option to provide to the workers. We can say them that they can choose option like both alternatives are good, or I can decide because they're similar. This option helps workers to reduce their random output, like when there is no clear difference and workers just randomly select left or right. It might further limit resolution because when people have option to say that there is no difference, the chances of choosing these options is higher when this option can be used in the cases where there is a clear difference, but workers wasn't his attention wasn't good enough to catch this the differences. And we have a question in chat. Have you seen any benefit of using higher resolution scale, like better, slightly better, or a slider? We experimented with those options, but we haven't seen observable benefit in these options. It sometimes helps users to help workers to express their judgment, like when they are not quite sure, they can use slightly better options rather than no difference. But overall, it does not affect it that much. Does not affect judgments that much. Okay, moving on. The last thing I would like to say here is that when you introduce a new possible options for judgment, if this option left unchecked, this option can be exploited, and the users can start using it in order to skip your task. And if you won't cover it with golden sets or stuff like that, the quality of our markup could degrade. So you need to cover it with monitorings with quality measures. The next one is biases, like left-right bias or stuff like something like that. We usually tackle the left-right biases by using even overlap and randomly swap options, so that half of the comparisons obtained in one order and half of the comparisons obtained in the other order. This way, we completely remove the left-right bias, even if workers tend to use one of the options more often than the other. Swapping it evenly completely removes this type of bias. And other biases can be reduced by using diverse golden sets. For example, if users regularly produce a wrong output, in some cases you can obtain lots of you can obtain examples of those kind of mistakes, and teach workers to answer in these cases correctly, rather than the way they are asking, rather than the way they are answering right now. And high degrees of subjectivity, it's usually the matter of quality control. Here is a list of options that can be used in order to implement the quality control in crowdsourcing projects. Like you can use golden sets and, for example, probabilistic golden sets. I will tell a little bit about it on the next slide. You can use majority vote and weighted majority vote, and you can model performance of workers by using some probabilistic models and some aggregation techniques. Probabilistic honeypots are honeypots, golden sets, which are correct not in the 100% of cases, but on some, but like 90% of cases or stuff like that. Well, this it means that you can create lots of golden sets, and you don't need to check every single one of them, because it's okay for workers to perform like the 75 or 90% of accuracy. Like the lower bound for accuracy is 50%, since you can obtain it with random outputs, since we have only two examples, or only two options in our project. And no human being can answer everything correctly, so the interval 75 to 90% is okay, especially when you are asking some, when you're comparing some non-trivial alternatives, and where you want to obtain subjective preferences from workers. A few words about golden sets. How do we produce them? We have two options how we produce golden sets. For example, we can break our response. We can remove some elements, some good elements. We can distort some elements, like decrease quality of images or font or stuff like that. Or we can include some random elements that are irrelevant to the user query. Also, we produce golden sets manually by using managed crowd or by ourselves. About aggregation, as far as I understood, there was other webinars so where this topic was covered or was already covered. You can read about it in detail in other webinar. There is a link QR code. So I won't spend lots of time on this topic. The last few, sorry, we have some questions in chat. First one is, what is the weight used for weighted majority? I will answer it very quickly. For example, traditional majority vote is when we just select the most popular option and compare answers of workers with the most popular option. And the weights can be used in order to select the most popular option. For example, answers of workers with higher quality can be treated more carefully rather than the answers from workers with lower quality. For example, a good worker, response of good worker can be counted twice as answer of response of worker with lower quality, or stuff like that. And the next question is, when you say 75-90% is okay, is 90% the upper bound because you wouldn't expect judges to perform better than that? Something like that, yes. We expect that we have some errors in our golden sets, so the overall quality would be lower because not every single golden set is correct, and if workers are doing their choices with high attention, they would choose incorrectly in terms of how we perceive their answers. And that's the first source of errors. And also, if we have a worker with 100% success rate, it usually means that there is some automation, some cheating and stuff like that. So it's usually a reason to look look closely to those workers who have a very high success rate, very high quality measure. Great. The last thing I would like to cover in my talk is some applications of side-by-side in our pipelines. For example, how do we gather pairs for our key point indicators plot? Since the side-by-side is a relative signal, we need something to compare with. And so what to choose in order to track progress on quality increase for our search engine. We use several options. We compare our current state of our search engine with the initial state, like we save the state of our search engine in the beginning of a period, and we compare the new state with this frozen state. The next option is when we compare our current state with some baseline state. Baseline means that it's not a production state, but some variant of our service with known properties. For example, some degradation, something that makes our search engine performance worse. For example, in lots of applications, we use as a baseline state a state where we swap positions from from second to fourth position. This type of change in our in search engine is well researched. It's an observable degradation. It's and users detect this change. So we can compare our production state with this baseline state and measure how much better we are compared to this baseline state. And as another option that we use to track progress is to compare our search engine with a competitor. Like we regularly compare our Yandex search with a competitor search and track how much better or worse are we compared to our competitors. So we have questions in chat. How do you track crowd quality change over time? Yes, I think I covered it a little bit. Yes, so we don't have much time.
Yes,
Let me.
Nikita, can we finalize because we're out of time?
I have 2 slides. Let me just one moment. We also sometimes use enriched side-by-side. It's like when we put labels on elements in our search engine. For example, search relevance judgment from other projects from when we estimate relevance of our engine, and we put labels on screenshots and ask our workers to compare variants of our search engine with judgments of relevance. And the last slide on my presentation is a screenshot of our internal tool where we conduct those experiments. It's quite similar to platforms where we conduct A/B experiments. We have control and experiment system. We have queries where we compare performance of those two options, and we have some aggregate statistics where we can aggregate statistics and query utilization where we can look deep down and find problems in experimental feature. So I think I took a lot more time than I was allowed. Thank you very much for thank you very much. If you have some questions and if you have some more time, I can try to answer it.
Can you share the last slide? Where is your email, maybe? And
yes,
of course, yes. If you have now any questions and you don't have to drop this session, just ask your questions in chat or in live. And you can also contact Nikita via his email or me when I will share with you the recording and the presentation. So if there is anyone who would like to ask something, please do it now. Okay, then I would like to thank all of you for joining us today. And have a very good day. Keep in touch. Thank you, Nikita, very much for your presentation. It was very, very, very interesting.
Thank you for the invitation. Hey, bye, everyone.
Thank you. Bye-bye.